nonlinear RF, and microwave circuit analysis using the harmonic balance method with TINACloud. In TINA version 16, TINACloud and later versions, you can analyze nonlinear RF and microwave circuits using the harmonic balance analysis method. The advantage of this approach is that it does not require detailed time domain simulation, which can be prohibitive for GHz-range signals. Instead, you simply specify the desired base harmonics, and the program calculates and displays the resulting spectrum lines. In this video, we demonstrate the application of the harmonic balance method in the online TINACloud software, where the high computational speed of the harmonic balance method provides a significant advantage. Example circuits for harmonic balance analysis can be found in the Examples, RF, HB folder of TINACloud. This frequency tripler circuit generates a 2.4 GHz output signal, exactly 3 times the 800 MHz input frequency, using a high-frequency bipolar transistor. To obtain the output spectrum, run harmonic balance analysis from the analysis menu using the settings above. Make sure to select V out in the output field. The following spectral voltages will be displayed. Observe that the dominant spectral component appears at the third harmonic, 2.4 GHz with an amplitude of 113.85 mV, while the fundamental component at 800 MHz is significantly lower at only 1.77 mV. This confirms correct frequency tripling operation. You can also display the spectrum lines graphically by clicking the diagram button in the dialog window. You can also specify the desired spectrum lines directly by listing their frequencies. This is particularly useful when some spectrum lines are far from the base frequency, as defining them as multiples of the base frequency would require an excessive number of spectrum lines. To illustrate this technique, open the AM Demodulator with PIN Diode.tsc circuit file from the Examples, RF, HB folder in TINACloud. This is a simple PIN diode detector circuit with an RC low-pass filter at its output. The AM signal is represented by 3 generators, one at the 1 GHz carrier frequency, and 2 generators forming the upper and lower sidebands, each spaced 100 kHz from the carrier. Now, calculate the amplitude of the modulating signal at the output of the PIN detector using harmonic balance analysis. Select Harmonic Balance Analysis from the Analysis menu. The Harmonic Balance Analysis dialog appears. As described previously, in this case we specify only the 3 known frequencies in the analysis dialog, rather than calculating all spectrum lines from the base frequency, since this would otherwise require calculating 10,000 spectrum lines. However, for the 100 kHz base frequency, we require the calculation of 5 spectrum lines, due to the distortion introduced by the diode. Now, press the Run button, and the values of the spectral voltages appear. Note that, although it is not required, the waveforms can still be calculated using transient analysis at these frequencies. Select Transient from the Analysis menu. The Transient Analysis dialog appears. Press the Run button. After a short calculation, the waveform of the AM signal and the demodulated signal appear in the diagram window. However, please note that at lower modulation frequencies, e.g., 1 kHz, the computation time may become prohibitive. We can also double-check the results of the harmonic balance analysis using Fourier series analysis. To perform the Fourier series analysis, select Fourier Analysis from the Process menu of the dialog window, then click Fourier series. The Fourier Analysis dialog appears. Set the parameter values as shown above. Press the Run button. The Fourier series spectrum appears. The calculated 208.75 mV at 100 kHz is very close to the 202.70 mV calculated using the harmonic balance method. Finally, note that, as we have seen in this example, the growing performance of modern computers makes time domain methods increasingly competitive with the harmonic balance method. This concludes our presentation on using the harmonic balance method to analyze nonlinear RF and microwave circuits.
For more information, visit our website at TINACloud.com. Visit our YouTube channel, youtube.com/user/TINA Design Suite.